Section 4.4 is on factoring quadratic expressions. Factoring is the process of rewriting an expression as a product of its factors. So for example, 12 has many factors, two of which are 3 and 4, because 3 times 4 equals 12. Many quadratic trinomials, that is expressions in the form ax squared plus bx plus c, can be factored into two binomials. So if a is equal to 1, in other words there is no coefficient of, or the coefficient of x squared is 1, we need to find two numbers whose product is c and whose sum is b. Let's take a look at an example here. So here we have x squared plus 7x plus 6. So c is equal to 6 and b is equal to 7. So I am looking for two numbers that multiply to c, in this case 6, and then the same two numbers have to add up to b, which is 7. So running through my times tables, 2 and 3, no, 1 and 6, yeah, maybe 1 and 6. So 1 and 6, so 1 times 6 is 6, 1 plus 6 is 7. So those are the two numbers that I'm going to put directly into parentheses with x's. So that's going to be x plus 1 times x plus 6. So the two binomial factors of x squared plus 7x plus 6 are x plus 1 and x plus 6. And if you wanted to check this, you would FOIL this, that is just distribute, multiply it out, and you will get that trinomial expression. Sometimes with a quadratic expression you can factor out a greatest common factor. So let's take a look at this example. We need to factor 4x squared minus 28x. Well, I notice that both of the terms in that binomial have an x in them, and both of the coefficients can be divided by 4. So in this case, my greatest common factor would be 4x, and then factoring that out or dividing that out of each of those terms is going to leave me with an x minus 7. So my final answer is 4x times the quantity x minus 7. You can check this by distributing, and you should get back to where you started. Now in some quadratic expressions, the absolute value of a is not equal to 1. In other words, there is a number other than 1 in front of x squared. In this case, it's a little more complicated. We're going to be looking for two numbers whose product is a times c and whose sum is b. So two numbers that multiply to whatever a times c is, and the same two numbers have to add up to b. We're going to use these two numbers to rewrite our middle term, to rewrite b, and then we're going to factor by grouping. Here's an example. So I need to factor 2x squared plus 5x minus 12. So I'm looking for two numbers that multiply to a times c, 2 times negative 12, or two numbers that multiply to negative 24, and then the same two numbers have to add up to b, which is 5. Okay, so there's a lot of factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. The ones that make me think of a 5 are maybe 3 and 8. So I'm going to try those. But clearly 3 times the 8 is not equal to 24, nor is 3 plus 8 equal to 5, so one of those has to be negative. In order to get a positive 5, my 3 has to be negative. So I'm going to use a negative 3 and an 8 to rewrite my middle term of 5x. So I'm going to write it as 2x squared minus 3x plus 8x minus 12. Okay? Notice that I really haven't changed anything. I've just taken that 5x in the middle and broken it down into negative 3x and 8x. Now I'm going to factor by grouping. I'll group my first two terms together, my last two terms together, and take a greatest common factor out of each set of parentheses. So the greatest common factor of 2x squared minus 3x is just an x, and that leaves me with 2x minus 3. Greatest common factor of 8x minus 12 is a positive 4, and that's going to leave me with 2x minus 3. And if it is factorable, and if you're doing everything right, you should end up with exactly the same thing in parentheses. So out of this first term here, x times the quantity 2x minus 3, and out of the second term, which is 4 times 2x minus 3, I'm going to factor a 2x minus 3 out of each of those. And when I do that, what I'm left with is the stuff that was out front, an x and a positive 4. So my trinomial 2x squared plus 5x minus 12 factors into the two binomials 2x minus 3 times x plus 4. A perfect square trinomial is a special type of trinomial that is the square of a binomial. So for example, the trinomial x squared minus 14x plus 49 is equal to the binomial x minus 7 squared. That makes it a perfect square because I'm taking a binomial and squaring it. The trinomial that I get is called a perfect square trinomial. And you probably remember this from Algebra 1 as well, that there's a little shortcut to factoring one of these. If I can notice that my first term is a perfect square, that my last term is a perfect square, and that my middle term is 2 times the square root of the first term times the square root of the second term, then I can factor it into square root of the first term plus square root of the second term, quantity squared. Same thing applies here. The only difference is I have a minus in the middle, so I'm going to have a minus in the middle there. So half of the trick to factoring this kind of trinomial is recognizing what it is. So I notice for this example, x squared plus 12x plus 36, I notice that if this is like my a squared, then a is going to be equal to x. This is actually a perfect square. Let's call that b squared, in which case b is going to be equal to 6. Now my middle term here, is that 2 times a times b? Is it 2 times x times 6? Indeed it is. It's 12x. So my factored form of this is going to take my a and my b, put those in parentheses with a plus in between them, and squared. So the trinomial x squared plus 12x plus 36 can be factored into the quantity x plus 6 squared. Now you can do this using one of the previous methods, but if you recognize that it's a perfect square trinomial, it's a lot faster. And then our last example here is a difference of two squares. A difference of two squares is a binomial that's in the form of a squared minus b squared. In other words, some perfect square minus another perfect square. And that factors into a plus b times a minus b. Why is that true? Because if you were to FOIL these two terms, you would get a positive AB for your inner, and you would get a negative AB for your outer. So those are going to cancel out, and you're left with just a squared minus b squared. This is actually really cool, easier to recognize, and I think even faster than a perfect square trinomial. So here's an example. We need to factor 81x squared minus 100. So if this is like a squared, then a is equal to 9x, because 9x times 9x gives me 81x squared. 100, if that's my b squared, then b is equal to 10. And using the formula, I put those numbers into parentheses, one with a plus and one with a minus. So 81x squared minus 100 is equal to 9x plus 10 times 9x minus 10. So in this section we took a look at different ways to factor quadratic expressions. Most of these should be familiar to you from Algebra 1. We looked at factoring a quadratic trinomial where a is equal to 1 and where a is not equal to 1. We reviewed factoring using a greatest common factor, and two special cases, that is factoring a perfect square trinomial and factoring a difference of two squares.